So far in this unit, we've talked about types of matter, so elements, compounds, and mixtures. We've looked at separating mixtures in the lab. We've looked at physical and chemical properties and also physical and chemical changes. Today we're going to look at some extrinsic properties of matter and how to kind of quantify them. So in your notes for the chemistry and homework, go ahead and turn to page 2.7 in the yellow section. So we're at page 2.7. And it says matter and matter measurement unit and unit conversion notes. So we're going to look at how to kind of work with measurements that we take in class, how to convert them to useful numbers, and really what a measurement is. Okay, so we're going to start with a measurement. A measurement is a determination of the amount of something. We've looked in the lab at different properties. We've described changes. We've described colors, shapes. Some of us have also done the separating mixtures lab, and we're able to measure and weigh things. That measurement is really going to tell us how much we have. So this is really an extrinsic property. Extrinsic. Okay? Now, a measurement has two parts. The first part is the number, and the second part is the unit. Okay, so it's really important to have a number and a unit. And as we saw in our first test, we really have to have both in order to earn full credit and to describe something properly. So if I tell you that I'm 5, am I 5 foot? Am I 5 years old? You really don't know unless you have the number and additionally the unit. Okay? Now, a unit is a standard amount of something that everyone agrees on. And without units, the numbers in the measurement don't make any sense, like we mentioned. So once again, you put a little star, always include units. Just to reiterate that one more time. Now, we have two types of measurement systems, and we in America really are the only people that use the English system. Everyone else pretty much is at the international system, but in America, we use miles, feet, inches, we use pounds, gallons. We have lots of different examples of American measurements, which is called the English system. The international system is also known as the SI system, and it uses only factors of 10, which makes it really easy to convert between. Now, the basic units we're going to kind of use, which you may have learned before, the length basic unit is called the meter. We're going to put parentheses M because that's the symbol we'll use for meter. Make sure it's lowercase. For volume, our unit is the meter cubed, which is the same thing as 1,000 liters. We're going to put an L for liters. Okay, I'm going to write up to the side here. Liters equals L, just so we're aware. And for the base unit for the mass is going to be the gram, which has a lowercase g. If you look at the right side of our notes right here, it kind of tells you the physical quantity, so what we're going to try and describe, and then the base unit we're going to use in the symbol. So if we're trying to describe length, so height or distance ran, we're going to use a version of the meter. It could be a kilometer or centimeter, but our base unit is going to be the meter. When we're taking the mass of something, we'll use the gram. Temperature, we're going to use Kelvin, which we'll talk about. It's a different version of Celsius, and it's different, much different than Fahrenheit. The amount of substance is called the mole, and we're going to really spend a lot of time on this in unit 4, I believe, 4, 5, 6. We're going to learn what a mole is in the chemistry world. And then the unit for time is the second. Okay, so these are all different ones that we'll use very often in this classroom, and a lot of them you'll use in your daily lives. Non-SI units, so things that we'll see that we have to learn to convert between, are liters, atmospheres, millimeters of mercury, calories, and joules. And we haven't seen these a lot yet, or you may not have seen them yet in your life, but we will work with them all this year. Now, the metric system is a very useful system that the rest of the world uses, and it's used most often because it's really easy to convert between. Okay, so there are all these different prefixes that have a numerical meaning. They're all based on factors of 10, and they're all standard. So we can use any of these prefixes with any of these symbols, okay, any of these units. So the first one we're going to talk about is kilo, okay. Its multiplier is 1,000, which means that 1,000 of the base unit can fit in 1 kilo of something, and its exponential is 10 to the third. Hecto is 100 and has an exponential of 10 to the 2. Deca is 10, so 10 to the 1. The base unit is just 1, so if I say I have a meter, I just have 1 meter. And then 10 to the 0, and we're going to go ahead and go deci, which is a decimal, 0.1, which is 10 to the negative 1. Centi is 0.01, which is 10 to the negative 2. Milli, 0.001. Hopefully you've noticed a pattern of the metric system. It will decrease by 10, a factor of 10. And same with the exponent, and the way you do that is just take away an exponent of 10. And a great way to remember this and a great mnemonic device is King Hector died by drinking chocolate milk. And we really like the by here because it's a base unit. It's not always meters. It can be meters, it can be liters, it can be grams, it can be any of these units we talked about above here. So make sure you really remember it's a base unit. Now, what are we going to do with all this stuff? Well, we're going to practice converting between the metric system and also other units. So the first thing you're going to do is you're going to find the prefix where you're beginning. So if I say I have 23.1 millimeters and I have to convert that to centimeters, you have to find the prefix where you're beginning. So I'm going to go up to my chart up here. I'm going to find millimeters. That's where I'm beginning. And then I'm going to determine which direction and how many spaces you move to the new prefixes. So I'm at milli. That's the little m before. And I wanted to go to centi. So I'm going to move to the left 1 spot, which means I'm going to move my decimal to the left 1 spot and apply it to the number. So take my decimal, move it to the left 1 spot. My new number is 2.31 centimeters. Let's try it again. So we have 32.6 milligrams, and I'm just going to regular grams. That's my base unit. So I'm going from milli all the way to grams, which is the base unit. So I'm going over 1, 2, 3 spots to the left, so my decimal place goes over 1, 2, 3 spots to the left. And you see this blank right here? That shows me I need to add a 0 there. So my number is now 0.0326 grams. In the third one, I'm going from centimeters to meters. I'm going from centi to the base unit. So I'm going to the left, 1, 2. So move my decimal place, which is at the end here, 1, 2. So I have 36.00 meters. In this fourth example, I have 35 milliliters to liters. So once again, I'm at milli. I'm going to go to the left all the way to liters, which is the base unit. 1, 2, 3 to the left. So I'm going to take my decimal, 1, 2, 3 to the left. And once again, I have that 0 I have to add, so 0.035 liters. Okay, I want you to pause the video right now, and I want you to do these other 4 practice problems on your own. When you're finished, go ahead and continue to press play, and then I'm going to give you guys the answers. But please do practice. That way we can make sure that we're understanding things. If you have any questions about how to do this or you're confused, down here in this section, go ahead and write a question mark and explain it, kind of write down what you're thinking at this moment or what you want to ask me in class the next time. All right, here are the answers. So we have liters, which is our base unit to milliliters. So we're going to go to the right 1, 2, 3. So I'm going to bring my decimal place 1, 2, 3 over. So I have 5, 7, 1, 2, 3, yeah, 57 milliliters. Kilojoules to joules. So I'm going to start at kilo, go to the right 1, 2, 3 places to joules. 1, 2, 3. So I have 500 joules. Kilograms to grams. Over here, I'm going to go to the right to grams. 1, 2, 3. 1, 2, 3. So I have 250 grams. And then I'm over here at liters, going to milliliters. Go to the right. 1, 2, 3. 1, 2, 3. So I have 2300 because I had 2 empty spaces there where I have to add zeros. Okay, so again, write any questions down you have there. But that's converting within the metric system. Pretty easy as long as you have this down. You will need to know this. So again, remember this: King Hector died by drinking chocolate milk, and you can just write it always. King Hector died by drinking chocolate milk. And I put the DA here because deca is different than deci. Okay, go ahead and flip your page. And we're going to look at dimensional analysis now, okay? Dimensional analysis is essentially converting between the SI system and the English system. Because sometimes we need, especially in science, if we're in America or the United States, we take a measurement in maybe something that's not a value in the metric system, and we need to convert it to that in order to kind of share it with the world. So dimensional analysis is our new best friend in science. We're going to use it all year long. Okay, it's really important that you guys are asking questions now and really practicing and getting a grasp for it, because we're going to use it all year long. Now the rules is that each multiplying fraction must have a numerator equal to the denominator. What that means is you're going to have a conversion factor. So a conversion factor. An example of a conversion factor that you might be familiar with is that there are 12 inches in 1 foot. So you see how my numerator is equal to my denominator? Another conversion factor you might be familiar with is that there is 1 minute. In 1 minute, there are 60 seconds. Those are conversion factors. Okay, my numerator is equal to my denominator. My numerator is equal to my denominator. Units in the numerator will cancel units in the denominator. We're going to talk about this in a second, so hang on to that thought. Now, to reach your final answer, you're going to multiply all the numerators, multiply all the denominators, and divide by the product, and keep the units that do not cancel out. This will all make sense when we start to practice. Okay, so some metric examples. We have 12.5 centimeters to meters. Well, how many meters is that? We could go ahead and start off by doing king, hectare, divided by drinking chocolate milk. We're at centimeters. We're going to move over to meters. 1, 2. So my decimal place is going to be moving over to the left. 1, 2. So I have 0.125 meters. That's how we just learned to do it. That's just regular converting between the metric system. If I want to use dimensional analysis, I'm going to use a conversion factor. So I have 12.5 centimeters. I need to figure out how many centimeters are in a meter. Well, I know from my notes on the previous page that in 1 meter there are 100 centimeters. That's my conversion factor. My units in the numerator will cancel my units in the denominator. So my centimeters over centimeters cancels. Now I'm going to multiply all my numerators, so 12.5 times 1, so I get 12.5, and then multiply all the denominators, so there's only 100, and they'll actually do that division. So we get my calculator, I'm going to do 12.5 divided by 100, and I get 0.125. And I have to remember my units, which is meters. And I box my answer. Let's do another example that you might be more familiar with. And if this seems strange to you right now, that's okay. You're just learning it. We're going to practice a ton all year long. All right, how many minutes are in 2 hours? I'm going to underline what I know. I'm starting with 2 hours. I'm going to circle what I'm looking for. Okay, how many minutes are in 2 hours? Whenever you start these examples, you're going to always put what you know over 1. So I'm starting with 2 hours. I put it over 1. I'm going to draw a long line. I'm going to draw my line right here. You're going to bring your words down. So I have 2 hours over 1. Bring my words down. I have hours. What do I know about an hour that could get me to minutes? Well, I know that there's 1 hour, there are 60 seconds, or 60 minutes in an hour. My units cancel because top and bottom. And then am I at my final destination? Am I at the minutes? Yes, I am. I'm done. I can put my equal sign. So I'll do 2 times 60 divided by 1, which is just 120. And I need my units. Minutes is what I'm left with. Minutes, and then box my answer. Let's do another one. How many seconds, so I'm going to circle what I'm looking for, are in 3 hours. So I'm going to start with what I know. I know that I have 3 hours. Draw my line, put it over 1. That's how we start every problem. Even if you have no idea what to do, you can always start with what you know and put it over 1 and draw your line. Everyone can do that every problem. I'm going to bring my words down, which is hours. What do I know about an hour? Well, I know that in 1 hour, there are 60 minutes. Cross off my unit. Am I at my final destination? I'm at minutes. I want to be in seconds, so I'm not there yet. I'm going to keep going. I'm going to draw my line, bring my words down. What do I know about a minute that I can get to from seconds? Well, I know that in 1 minute, there are 60 seconds. My minutes will cancel, and I'm left with seconds. Is that my final destination? Yes, it is. Put my equal sign. So I'm going to do 3 times 60 times 60, because I'm multiplying all the top numbers. So I get 1080, 800. And then multiply all the bottoms, which are all ones. So my answer is 10,800 seconds, because I always have to have that unit. Alright, let's practice one more. So how many inches, once again I'm looking for inches, are in 2 yards? Start with what I know, 2 yards. Put it over 1 and draw my line. I'm trying to get to inches. I'm going to bring my words down first, always. What do I know about a yard? Well, I know that in 1 yard, there are 3 feet. Cross off my yards. I'm at feet. Do I have my final destination? Nope. I'm going to keep going. So I'm going to bring feet down. I know that in 1 foot, there are 12 inches. Am I at my final destination? Yes, I am. And the feet and foot will cancel out. So to get my answer, I'm going to multiply all the numerators and divide it by all the denominators. So I have 2 times 3 times 12. Okay, so I'm going to go ahead and put that in my calculator. 2 times 3 times 12, which is 72. My numerator, or my denominator, is 1 times 1 times 1, which is 1. So my answer is 72 inches. Alright, these are kind of smaller examples of what we'll work on in class and what we're going to be using the rest of the year. But the process is really important, okay? So basically, we're going to do step 1, write what you know. Put it over 1. Okay? Step 2, you're going to draw your line. Step 3, bring your words down. Step 4, this is when you have to use all of this information right here and your brain. Okay, so to find a conversion factor. And then step 5, you're going to keep going until your desired unit. Okay? That's kind of the step on how to get there. And then once you get there, you're going to multiply numerators divide by the denominators. And you're going to include your unit. Okay, so here are all these steps that really lead us to succeeding in dimensional analysis. Write what you know, put it over 1. Draw the line. Bring your words down, find a conversion factor, keep going until your unit, and then multiply, divide, and include your unit in the answer. On the next page, page 2.9, there are a couple practice problems. You guys could go all the way up until number 6, so numbers 1 through 5 if you would like to practice. I'll have those answers in class for you. Also on your homework, so in your yellow section on page 2.21, there are dimensional analysis problems. We haven't learned sig figs yet, so you can kind of ignore this section for right now, but you can do the conversions. Also, there's metric to English conversions and 2-step conversions on pages 2.2 and 2.22 and 2.23 that you can work through. Alright, so try and get as much as you can done. Take notes on what you have questions on, and I will answer as many questions as possible. And we're going to work on this all year long.